Hi there, and welcome to Algebra 2 CST release question number 61. It says a certain radioactive element decays over time according to the equation y equals A being the initial amount, and then 1/2. Notice this is less than 1. That's why it's a decay type function. If this is less than 1 or in between 0 and 1, it's going to get smaller and smaller depending on how large or small that fraction is, more or less quickly. But if it's less than 1, it's going to get smaller. And then this is t in time, looks like in years, over 300. So I already kind of said A was a number, the initial amount, but the number of grams present initially. T is the time in years. If 1,000 grams were present initially, how many grams will remain after 900 years? So I'm just going to take this right here. Looks like this one's just a matter of plugging in some numbers and getting what the correct answer is from there. So my 1,000 grams present initially, this is equal to A. And then how much will remain after 900 years? This is going to be equal to my t value. I'm going to plug in here. I've got y equals 1,000 times 1/2 to the 900 over 300 power. So I plugged in that. This can be simplified to 1,000 times 1/2 to the third power. The two zeros would cancel with the two zeros here. 9 divided by 3 is 3. And then that would be the same thing as, you can think of 1/2 as 1/2, or 1/2 to the third power is 1/2 times 1/2 times 1/2, or in other words, 1 cubed over 2 cubed. That's another way to think of it. Either way you think of it, you should get the same answer. We should get 1 over 8. So this is the same thing as 1 over 8, meaning that you have this. I could write as a fraction. I could put this over 1. If that helps you think about it, great. And then this is going to be equal to 1,000, same thing as 1,000 divided by 8. Now you might not know what 1,000 divided by 8 is off the top of your head, and so we could do some long division, seeing that we can't use a calculator on a test like this if you're preparing for the CST specifically, at least. 1 into 10, or 8 into 10 one time, subtract 8, you're left with a 2. This will go into there twice. Subtract 16, 2 times 8, 16, and we're left with a 4. Carry the 0 down. 8 into 40, 5 whole times. Subtract 40, that's 5 times 8. You're left with nothing. It looks like that then is your final answer. So 125, this would be 125 grams. That's how much of the element, the radioactive element, is left over after 900 years, it looks like. So 61 should be choice C.